we need to draw down massive amounts of carbon dioxide from the atmosphere. And at the moment, we're not that great at drawing down massive amounts of carbon dioxide from the atmosphere. A recent National Academy study found that to prevent 2 degrees C of warming, we'll need to remove 10 billion tons a year from the atmosphere by 2050 and 20 billions annually by 2100. By way of scale, the world pumps out about 50 billion tons a year today. So we're talking about a carbon removal industry operating on the emission scale of like half the global economy by the end of the century. Only it's harder to remove CO2 once it's been dispersed than it is to generate it in the first place. We are staring at this daunting scale because we've pumped out massive amounts of greenhouse gases into the atmosphere for well over a century, because we've still done relatively little to decarbonize our economies to date, and because there's still some crucial missing pieces in our technological toolkits. Those include ways of affordably cleaning up sectors like aviation, cement, steel, agriculture. Do know that our natural systems are really good at drawing down CO2. They do it naturally. It's part of the natural carbon cycle. Our forests do it, plants do it, soil, oceans, certain minerals. But they don't do it as fast as we need to do it because of how much faster we are accelerating our own emissions. And frankly, they face some big challenges so far in terms of, not the physical capacity, but in terms of setting up the human systems required to accelerate and scale up these processes, figuring out ways to measure and verify that they're actually happening, ensuring that they're happening in at least a durable way, if not even better, a permanent one. Surprisingly rapidly rising number of major companies now, just in the past, even if just last 18 months or so, are looking to various types of avoided emissions, carbon removal, offset strategies to slash their carbon footprints. And we're seeing rapidly growing carbon markets with all sorts of third-party verifiers, brokers, market operators emerging. And several crucial issues spring from all this. First, given that more and more companies and countries are relying on these tools for major parts of the decarbonization and net zero efforts, it's just going to become that much more important that we're doing things right, that these are efforts that these carbon removal efforts are real and reliable and measurable. Second, there's likely to be a limited supply of actually quality, credible offsets and ways of doing carbon removal. So we really can't afford for companies and countries to rely on them for the things that we do know how to clean up. So even if doing the root causes is a more expensive process for them, there's a real risk here that people and countries will opt to do forms of carbon removal on paper in lieu of the harder work of cutting emissions. Given what I said at the beginning about these projections, we need to do all of these things. Third, from a fairness perspective, to the degree that there is sort of a limited supply of these things, arguably you could make the sort of moral case that they should be reserved not for giant profitable companies in rich nations, but rather thought of as more of a buffer for poor nations that aren't as far along in development and may have to rely on fossil fuels for longer periods than the rest of the world before they kind of get to that point of economic development where they can make those shifts and where the cost of renewables and other clean options are coming down. And fourth, as more and more players come to profit from these building carbon markets, whether it's voluntary or government-based offsets programs, it's going to get harder, not easier, to enact reforms when it becomes clear that there are problems with it. So this is something I think is really important, is that it's going to be crucial that we do the work today to talk about these things in an open and honest and constructive way.
So Lowercarbon Capital, we invest in early stage companies that do a number of things, but one, reduce emissions from point sources by a substantial amount. I want to emphasize that we're laser focused on the chunks of the economy that are really a big pie of greenhouse gas emissions, and I'll note some examples of that. Secondly, we invest in companies that remove CO2 from the atmosphere, and so that's companies like Maddie's that she'll get a chance to talk about, that do it from a nature-based standpoint. We call generally nature-based solutions, as well as tech-based solutions, direct air capture, biomass, and then tools that enable those two to take place. So whether that's, it's carbon accounting, like with, I think we'll hear from Landon, who does great work there, and Gregory, as well as monitoring of CO2 emissions. Those are important tools in understanding the way the 1 and 2 fit into the general greenhouse gas emissions landscape. And then the third thing that we focus time on is on better understanding how, if we don't do 1 and 2 fast enough, we would have to essentially buy more time or find ways in which humanity can be comfortable in the warming state that it will be in. And that's critical to be able to, live comfortably, live humanly, to be able to do the things that we want to do, but mainly for, I think, in large parts of the Southern Hemisphere are going to be in states that are generally very uncomfortable if we don't reduce the atmospheric concentration of CO2 at this point. So in terms of I would just want to highlight some of the kinds of things that we invest in that are very big chunks of that contribute to very big chunks of greenhouse gases that are emitted today, and those include clean steel, decarbonizing cement, fertilizer, aviation, and maritime transport. Those make up, I think, altogether some 80% of greenhouse gas emissions.
I'm Landon from Wren. We're a website that lets you calculate and offset your carbon footprint, like James was saying. Basically, it works by asking you a few questions about your lifestyle, like how much you drive, how much you fly, that sort of thing. And then we tell you how many tons of CO2 you're responsible for from that lifestyle. And then we make it easy for you to offset that CO2 by funding projects that plant trees, protect rainforest, or otherwise reduce and remove emissions. I started Wren in 2018 when my co-founders and I were in college. The Intergovernmental Panel on Climate Change had around this time just published a major report that basically summarized how bad the impacts of climate change could get and how critical it is that we limit warming and that we do it ASAP. For my co-founders and I, it was a bit of a wake-up call. We knew that climate change was a huge problem, but it felt like something that someone else would fix. And so we read this paper and kind of realized like, whoa, things are really bad, and felt a lot of like existential angst around like, oh my gosh, what are we gonna do? Like, we're just like, we need way more action. It just doesn't seem to be happening. Felt pretty powerless in the moment. I wanted people to understand the impact of their own daily life. So we built a tool to calculate your carbon footprint. And then we launched in June of 2019 and have been iterating on it ever since. Carbon offset projects have some well-defined, measurable mechanism of reducing CO2 in the atmosphere, like planting trees or destroying refrigerant emissions, or even using machines that are sucking carbon out of the sky. So the carbon offset market has existed for a few decades, mostly thanks to purchases by big corporations to claim they're carbon neutral or under some policy set emissions target. But as James was talking about, the market's often criticized for how ineffective a lot of these offsets are. One kind of striking example here might be if someone purchases a forest to protect it, when in reality, the forest was never at risk of getting cut down. If someone else had bought it, they would have kept the forest standing as well. So there's lots of sort of loopholes or challenges like that when it comes to carbon offsets. So even though there's this existing market, we have to figure out what the future of that market looks like if we want to scale it up. And put another way, there's a lot of the solutions that we need to end the climate crisis are kind of ready to go today. There's a clear market incentive. So for solar panels and electric cars, those are going to reach mainstream adoption pretty easily at this point. Policy can help a ton, but they don't need this financial incentive to kickstart at this point. But for tree planting at scale or lots of negative emissions technologies, we aren't really there yet. We kind of need more robust markets that are going to fund and kickstart these projects. So with Wren, the idea is that regular people can help kickstart these markets and fund the most effective, transparent carbon offset and negative emissions techniques. So we can hopefully start scaling this up to eventually reach a point where we're removing gigatons of CO2 from the atmosphere.
So for Living Carbon, our mission is to responsibly rebalance the carbon flux using the unique technical abilities of humans. And we do this using the ability of plants to capture carbon. So every organism since the beginning of time within the plant family has been able to photosynthesize. And we specifically focus on developing technology that improves both the carbon capture and the duration of storage. Historically, we've really used genetic engineering to improve yield for humans' own consumption, which is actually, if you think about it, the opposite of sequestration. All of the food that we eat ends up being part of respiration. And so we believe that humans need to start seeing ourselves as part of this global ecosystem and not purely here just to use our technology to benefit in isolation from it. There are many different ways to remove a lot of carbon from the atmosphere, ranging from spraying sulfuric acid to block out the sun, which is not technically carbon removal, but and putting genetically engineered microbes into the oceans, as well as many other more extreme geoengineering ideas. We believe that out of all of those things, trees are relatively safe. They're not going to get up and run away, and you can do it in a way that's a closed ecosystem. And our hope is that Living Carbon's seedlings, we focus on two things right now. The first is improving photosynthetic efficiency. So this is basically taking a toxic byproduct of photorespiration and breaking it down with less energy. And the second is slowing the rate of fungal decomposition of trees. So
Regen Network, we have a couple, I want to share a couple of our assumptions about sort of foundational assumptions about this complex emergent issue that we're talking about here, climate. So number one, our assumption is that the Earth has full capability to, within its own living carbon cycle, sequester 100% of the carbon that's been emitted since the beginning of the Industrial Revolution. Soils, forests, kelp forests, coral reefs, mangroves, estuaries, wetlands have enormous carbon sequestration capability. The question is really social. The question is about the humans and how we interact with those living systems, and if there's no good word in English for like working lands, right? We talk about agriculture and forest and forestry and fisheries in a way as if they're somehow fundamentally different. But the pattern of a human relationship with an ecosystem in which we're taking something that's produced by photosynthesis at the end of the day and consuming it for food, fuel, or fiber. That relationship, that fundamental relationship between humans and the greater than human world is really what needs to be examined. And as Landon mentioned, Project Drawdown, amazing resource. Many friends who are part of the group that put together the research there, and all of the solutions exist, right? So from our perspective, and again, I'm sort of sharing some of our assumptions. Our assumption is really this is sort of a social and economic question at the end of the day. How do we change our the economic conditions such that it is more profitable to operate a business that over time increases the sequestration rate of that soil instead of stripping that soil of its soil carbon year after year after year through whatever the agricultural practice is, tillage, for instance. What does it mean for a living biodiverse forest to be worth more standing than it does being pulped for toilet paper? What does it mean for the incentives at a systemic level to transform so that we can unlock entrepreneurship and agency and investment in order for this problem essentially to solve itself? And when we ask that question, the answer that emerges to us is we have to have a rigorous public infrastructure that makes it very cheap and very transparent to create claims around what in economic theory is referred to as a public good. It's hard to privatize, it's hard to commodify. We're talking about the sequestration potential of a parcel of land How do you create economic agreements about that? And it all boils down to who is saying what about where, using what methodology, and creating rigor and transparency around that core question, and then scaling that to be able to create different economic agreements, derivative projects, products, bonds, credits. All of these instruments are the way that we contract with one another and align our incentives. And there's a whole world there, I believe, that's in the process of becoming. So my parting thought is, really, we're at, because we have to be, we are not now within the next 3 years at peak emissions, and we're at peak, atmospheric carbon. So we're now going to start the decline. And so what that means for entrepreneurs is there is more atmospheric carbon right now to capture through photosynthesis or direct air capture or any of the other methods than there will be in the future of humanity. So get busy if you want, because now is the time to start drawing that down, capturing it, storing it, sequestering it, because it's going to get harder and harder and scarcer. That carbon there's never going to be more than there is now. So now is the time to start moving and shaking.
Everyone loves trees. It's pretty, the one thing we all know is that they suck in CO2 and breathe out oxygen. So it's promising, it seems promising and straightforward. But there have been challenges in, on the ground reality with afforestation and reforestation projects in the past. There was a Stanford study last year that found that Chile's earlier efforts to subsidize tree planting ended up incentivizing the replacement of native forests with tree plantations, which actually reduced biodiversity and at least didn't increase carbon uptake. And then there was just a Bloomberg story last week or the week before that concluded a similar kind of perverse incentive problem had happened, taken root in the Sowing Life reforestation program in Mexico. So I was curious if these, if Wren is taking steps to ensure like the tree planting projects aren't coming at the cost of native forests and running into some of these sorts of problems in its East Africa project or wherever else you guys are working on tree planting projects.
Yeah, great question. So like we were talking about earlier, there's been this history of the carbon offset market for a while now, and there's been a lot of high profile, just like basically disasters where project is supposed to be doing one thing, like maybe protecting rainforests here, and then you do an analysis later and it's like, oh my God, there was a ton of illegal logging here. There's a ton of wildfires rolling through. So definitely you have to look at all of these projects, really have to scrutinize it. Like there's third party kind of standards that verify the projects are working and do great work in that aspect. But even the standards that are popular today, we don't have the confidence that we want to see to be able to just rely on one standard. So I think that's why folks I think Gregory's basically doing a lot of work in this space to make it so we can maybe have some standards we can trust. Basically like a checklist of stuff you want to check off when it comes to tree planting projects. Certainly one of them is they have to be planting either native species or species that are going to do well and provide helpful benefits for that area, like nothing that's especially vulnerable to pests or more likely to burn or going to cause some ecosystem damage. The specific project in East Africa is kind of interesting that you mentioned, James. They're basically funding subsistence farmers to grow trees on their land. And often that means planting trees that are providing other benefits like growing fruit or providing shade or kind of windbreaks at helpful areas. That's another way we can maybe have a bit more, ensure that these trees are staying standing, is by making them valuable in the work that they're doing for the people who live in the area. Another potential issue I'll touch on here too is land ownership. So you can imagine one awesome group owns a piece of land and they're planting a bunch of trees. It's going really great. And then eventually 20 years in or something, they run out of money, something happens, that land changes hands. All of a sudden, next landowner is going to cut down all those trees. So not a good scenario for that carbon offset project. one of the solutions we're seeing emerge for one of the projects we fund in the United Kingdom is putting land into kind of like a long-term trust or covenant that ensures beyond the company's longevity, that the future landowners will still have that trees growing. So in some countries that won't work, like areas where there's a weaker rule of law, you can't have that guarantee of legal instruments that are enforced by a government like the UK or US. But in countries where you do have strong rule of law, that's maybe one other helpful solution here. And the last thing I'd say is anytime you're planning these projects that are kind of nature-based solutions, you always have to think about what is our risk profile here? How likely is it that this is going to reverse, that something is going to go wrong and the carbon's going to be emitted again? Ideally are publishing like photos of every tree planted and growing, tied with GPS coordinates, tied with measurements of those tree trunks every 18 months or so. Lots of times satellite imagery is really helpful with sort of painting the picture and just having a better perspective on what's going on with these projects. So there's a huge element of transparency that's really important here.
Got it. Cool. Maddie, so I haven't done a ton of coverage in the past of the sort of plant genetic issues, but the one thing I know about it is it's hard. that you know, from isolating the particular genetic sequence that's at work in terms of producing the positive thing that you want, to ensuring that whatever changes you do make aren't coming at the cost of other critical functions. And I'm also guessing that, I don't know exactly where you are in the development space or how much you're able to say about where you're at in the development space, but just based on how long the company's been around, I'm guessing you don't have like fully engineered or engineered trees that are like full maturity yet. So I guess I'm curious if there's still some science and development risk here that, you know, whatever you have achieved may come at the cost, like, I'm just imagining like trees that don't have the root system to support the greater size we're talking about, or the more rapid growth, or they end up needing 4x the water, or certain types of soil. I don't know, but can you just talk about sort of what kind of like scientific risks you may have, and how you guys are sort of dealing with that?
Yeah, of course. So I think Living Carbon, we really stand on the backs of giants, people that have been working within the forest biotechnology space for 20, 30 years, who do have mature tree stands. So we're able to learn a lot from them. So our first demonstration forest with Oregon State University, one of the professors there has been doing this, you know, for as long as I've been alive. And I think one thing that we think a lot about is just measuring all of the ecological considerations and very thoroughly understanding from a biochemical perspective exactly what's happening, right? So a lot of people focus on modifying Rubisco, which is the most famous enzyme in the world. And a lot of those efforts have not been very successful, just because the enzyme itself denatures very quickly, and it's just incredibly challenging to modify. So we actually rely a lot on work that's been done in crops previously. So the similar pathways have been used in tobacco, in soy. Nothing has really made it to market yet, but the science has really been something that's been worked on, you know, for a very long time by multiple institutions. So for us, you know, we actually see when it comes to root growth is a lot faster and more complex and robust if you have a photosynthesis enhanced seedling. Of course, you know, there are other considerations, but I think you have to make sure that you are understanding the fundamental biochemistry around how you're changing and the genetic modification that you're making, and how you're changing the way in which the plant is capturing carbon. So, and then the other thing that I'll add here is, you know, we have been around for a short period of time. There have been other companies, particularly around biofuel, that have worked a lot on reducing the cellulose to lignin ratio as a means of improving biochar, or the ability to use poplar seedlings to, you know, make biofuels. And unfortunately, that's less of a market right now, but we rely a lot on the protocols that have been used since the early 2000s on how to do that. And, you know, I think for genetic engineering and gene editing itself, of course, it's incredibly challenging. the way I like to think about it is we're doing something that has not been done before. And so we have had to find people that have done specific parts of this thing and know how to do specific parts of that thing. And then combined together, we can hopefully, you know, create these seedlings. And we're really excited to have them planted shortly. I can't say much more about that, unfortunately, but.
You know, I did a story about soil carbon a while back, and I talked to a number of soil scientists and others, and there are, you know, a number of concerns about, not that there isn't a lot of physical capacity to do this, but that that soil science is sort of still, there's a lot of uncertainty in terms of how much additional how much additional carbon is actually being taken up through, under what techniques, under what conditions, under what climate conditions, soil types, depths, etc. And so there's very much a strong feeling among the folks that I talk to is that you really have to do a lot of sampling to know. And the other thing that came out of those conversations is that our ability to use satellites to accurately measure soil carbon is not, you know, there's not a lot of science that says that that's an easy thing to do. And that seems to be a big component of your company and your approach. So can you talk about why you're confident that you guys have figured out a way to do this, and otherwise how you're sort of getting around the challenge of this, just the variability of carbon uptake in soil from place to place, time to time?
One is we have to ask, sort of ask about the underlying incentives of the critics. So there was recently you know, like a lot of sort of a flurry of criticism from a certain, you know, well-regarded sort of science NGO, who at this moment shall go unnamed. They had a lot of interest in forestry-based credits. Okay, so just flagging that we just, not to, like, I'm not trying to throw shade, I'm just trying to say we have to, like, look at the larger structure, because this is it's about science, right? It's about having replicable, peer-reviewed scientific processes underpinning what's happening. And science is also run by people, and people undermine each other's science for different economic concerns. So just like to pin that as something that I think is really important to talk about in this concept about how we create social consensus about what is actually happening somewhere, that people aren't going to go look at that soil, right? So sort of point number one. Point number two, there is a dearth of good science that is using remote sensing combined with soil samples. It's just, there's just hasn't been a whole lot of departments that are well endowed to do a lot of studies. What I can say is all of the studies that are coming out, there's been a bunch of them in the last year, are all like right on the money, trending with the same sort of conclusions, which, and those conclusions are that combining sampling and remote sensing increases the precision and accuracy of our modeling and estimations of soil carbon sequestration. So it's really about combining the two. In addition to that, using remote sensing, you can what's called stratify the sample set. So you can, instead of having like a random grid where you're just sampling every 10 meters or every 20 meters or something, you can actually stratify for topography, soil type, and you basically create a layer, and you can ensure that you're getting samples from all of the important sort of subcategories across a landscape. And that massively increases the efficiency of monitoring, verification, and quantification. And essentially that's what we're doing, underpinning our approach. And it's not just us, there's a whole community of people who are now sort of approaching this using either Sentinel-2 data, or which is published by the European Space Agency, which gives us a global refresh every 5 days of the entire planet, right? With 13 bands of spectral imagery. And what people need to understand about sort of multispectral remote sensing is we are measuring. It's a measurement. We're just like a microscope, electron microscope is a system for measurement. So what are we measuring? We're measuring the reflectivity, and we're correlating that to the ground samples, right? And so in a very simple way, you could conceptualize what's taking place as, you know, how green is the plant, or how dark is the earth? And how does that correlate to the laboratory samples that did bulk density or soil organic carbon quantification?